So in the previous video, we saw a very quick method of calculating hypsometric curves. Here in this video, I'm going to introduce one more method through which you can calculate hypsometric curves, and they will look more like the curves that we always read for hypsometric analysis. Okay, so there are going to be few steps that we are going to learn in this video now. So for that we need, okay, I'm just going to clip out one of the drainage basins. Let's clip out this drainage basin from here. Okay, so for that I need this selection tool. Select features by area or single click. Okay, I'm going to clip out this particular drainage basin for our second method. Okay, and for that I'm going to go to raster, extraction, and clip raster by mask layer. Okay, so my input layer will be filled DEM and my mask layer will be drainage basins, and I'm going to use selected features only. Okay, so let's assign a no data value to our output, which is going to be the same as we have in our input. Okay, so here we are going to get the no data value, and this is the same value we are going to paste there. Okay, so let's paste this value here, and let's keep other parameters as it is. If you want, you can go through them one by one. Okay, now let's save it to file. Okay, so I'm going to name it as DEM, or let's say drainage basin dem. Okay, then save it as step file, click on run. Okay, so now we have clipped out our DEM of interest, and I'm going to remove this layer from here. Okay, and I'm going to switch this off drainage basin boundary. So let's style it a little bit, and for that I'm going to use this open the layer styling panel from single band gray to single band pseudo color. Okay, and here I'm going to invert the color ramp, and let's use the discrete classification, and from continuous to equal interval, and let's classify this into 10 classes. Okay, and we are going to check what is the maximum and minimum value, and for that you have to set here minimum and maximum. Okay, so let's see what is the interval difference between these two. For example, I'll use the calculator here. Okay, subtract this from 1233, and this is approximately 739. So if we take the interval of 100 meters for our contours, then it will suffice our objective. Okay, so I'll just close it, and now in the search toolbox I'm going to write contour polygons. Okay, contour polygons, and here of course our input layer will be drainage basin DEM, and the interval I'm going to use, that will be 100 meters. Okay, so we will have two columns in elevation minimum and elevation maximum. Okay, and then let's save this file as area elevation. Okay, let's save it, click on run. Okay, now let's open this attribute table, and here we can see there is one anomalous value, so I'm just going to change it to 0. That doesn't make any difference. Okay, so if I dock this attribute table, what exactly we have got? We have got, if I select this and if I use this zoom map to the selected, this is the uh, this from 0 to 500. For example, this boundary we have taken as 0, and this is the maximum elevation of this contour, right? And this is what we require while calculating the hypsometric curve. We need the lower boundary and the upper boundary and the area between these two boundaries, right? This is what we require. So now our next task will be to calculate the area between this polygon, area of this polygon. Okay, so we will use field calculator for it, and I'm going to create a new field which will be called as area square kilometer. Okay, so that we can use as decimal number. For that, I'm going to use the function $area divided by, okay, and click on OK, right? Okay, so why only one value is calculated? Because we selected that, right? So let's refresh it and deselect uh, this row, and we will again go to field calculator. Now this time we have to update our existing field. Okay, area square kilometer and area divided by 6 times 1000, 6 times zeros, okay, of course, and click on OK, right? So we have got the area for all the contours, all the contour polygons, and this is what we require, right? So of course this is our absolute value. Okay, now if you want to calculate the ratio, that you can definitely do that, and you can do all this analysis using the Excel sheet. Okay, now let's take both our sheets, both the attribute tables to Excel sheet as a CSV. Okay, so we have to export it as a CSV from this entire list drop down menu. You have to select the CSV. Give it a file name, call it as area elevation values, on save, and here make it no geometry, click on OK. So yes, I'll remove both of them from here, and now we will directly go to the Excel sheet for further analysis. Okay, yes, so let's open this one. Here we have elevation minimum, elevation maximum, and area in square kilometer. First, I'm going to sort elevation maximum from largest to smallest values. Okay, I'm going to expand the selection. Sort. Now, this is the area in square kilometers. Okay, so we are going to use the elevation maximum and area square kilometer columns for our further analysis. Okay, so let me arrange these two columns in a way that we can frequently plot our graphs. Okay, so I'll just cut it from here, and I'll paste it after the area and square kilometer. We do not require these two columns, so I'm going to delete these two columns for now. Okay, so here first I'm going to calculate the cumulative area. Okay, cumulative area, right? And you can also calculate the cumulative area percentage, whatever whatever you like, you can calculate. So for that, our first value will be as it is, and for our second value we have to add this with the first value. Okay, again repeat the process. So this is the total area of the basin. Okay, so now, so these are the absolute values of the area and elevation. If you want, you can prepare the same graph which we prepared before using the absolute values, right? So this is what you prepared before as well, but the direction was different. Okay, because there the elevation was calculated in a different way. Okay, and you can adjust the axis. So this is our x-axis, which is the area, and this is our highest value. So I'm going to copy it from here to here, and of course this should be, this is the smallest value, minimum value, I'll keep it as 0. And here also from 500, minimum value will be 500 and our maximum value will be 1400, right? 1400, or you can also make it lesser if you want. You can also keep it 1300 or something. Okay, so I think this looks better. And this is how you can plot your cumulative or absolute values. Okay, so this is the graph that we have already prepared. So but now our second task, in this video we are going to learn about how to calculate the proportion, right? A divided by capital A, H divided by capital H, and the values, right? So yes, first let's calculate A divided by capital A, right? So our A will be this value, okay, equals this value divided by the total drainage basin area, right? So this should be the value, right? If I'm and here again we have to take B11, right? The total area. Let's correct it manually. Or you can just take the value here. Okay. Okay. So yeah. So this is our A by A. And now we can calculate H by capital H. So that should be our elevation at a point divided by the highest elevation, which is 1400 only, equals to 1300 divided by 1400, okay, equals to 1200 divided by 1400, the highest elevation. 1100 divided by 1400, again 1000 divided by 1400, now it should be 1400. Sorry, I think it should be C2 only. 1400, right? So these are our proportion values. Now we can make the curve, hypsometric curve, using these two columns. Okay, so you in the Excel sheet you always have to when you are doing it, so now let's plot a graph for it. Okay, so select all these values, insert a graph. Okay, now we will adjust the values. Okay, so the easy thing is that these values will always vary from 0 to 1. Okay, either I mean it is, if it is on the x-axis or y-axis, whatever it is. So let's wait. Okay, and here it is, of course it is between 0 and 0 and 1, but here the value is, the slowest value is 0.3. So let's keep it like this, and you will notice that both these graphs are similar, right? They both, but the way you represent it, it is different. Okay, so this is the proportion. If I put, I'll remove this, if I put the axis title here, so this is my H divided by capital H, capital H, and this is my A divided by capital A, right? So this is how you can create your different hypsometric curves using the absolute value and also using the proportion values. Okay, so I hope these two methods are clear with all of you. In the next video, we are going to learn about the calculation of hypsometric integral. In the same way we did using the Excel sheet, you can also calculate the hypsometric integral here as well. You will get the same value, that is 0.5, right? In the same way you can calculate, but we will use, in the next video we are going to use the digital elevation model for calculating our hypsometric integral using some processing algorithms in QGIS. So see you in the next video.